Okay, so tomorrow is your quiz. All right, I mentioned to you that anything that was on WebAssign kinds of problems were fair game. I did not put any word problems that had 3 equations and 3 variables. So the last 2 examples, we'll go over it in a second. The last 2 examples that I have on the review, at the very end, the word problems will not be on there. You absolutely will have word problems. You might have an interest problem like the first one. You might have a break-even problem where you're figuring out how many of what item needs to be sold to break even. Hannah brought to my attention that this question here also asks for the corresponding revenue. So where they ask that, you would then take this answer, which you got for X, and you would plug it into the revenue. So it'd be 12.28 times your 47.74. So if you multiply that, 12.28 times 47.74, you get about 58,624 and 72 cents. So that was just the second part of that question. You will have a question that is non-linear, meaning you could very well have more than one answer, right? Make sure you guys are going back and checking your work. We did not put any on there that was solved by a specific method. We just said solve. I will be very specific. If it says in the directions no decimals, then there's no decimals. You need to leave it as a fraction. If it says to make it into a decimal, then you need to follow the directions. Okay, just pay attention to what you're doing. It's very important. Does anybody have any questions on this first page? I'm going to go through each one. If you have any questions, just let me know. No? All right, the second one. All right, you have a very basic problem. You'll have a couple of these. Here are 2 equations. Solve them. Solve by substitution. Solve by elimination. Understand the difference here, guys. Look at this. This is an infinite many solution. Look at what the answer looks like. 0, 0, and the other side of the equal sign is a 0. If you come out, say you have something like this. This is after I've multiplied, both equations by whatever to get the coefficients to be the same. So this cancels, and I have equals 17. What kind of a solution is that? That's no solution. Do you guys visibly see the difference when you algebraically work this out as an infinite many and no solution? Infinite many, everything will cancel out. You have zeros on both sides. No solution will result in an untrue mathematical statement. Now, guys, understand, say this is an 8-point question. If you work everything out right, but you tell me this is no solution, I'm not giving you any credit because you don't understand that when everything cancels, it's infinite many. If you tell me this one here is infinite many when it should be no solution, you're not getting credit because you algebraically can cancel things out. You have to understand the concept behind how and why you're answering specific questions. This is an Algebra 1 skill. Understanding what that means when everything cancels out on one side and not on the other is your upper level thinking skill. So make sure you guys are aware of that. Another thing I want to bring to your attention, all right? Some of you like substitution more than you like elimination. That is fine. I did this problem using substitution. I would never do that in real life. I would solve this problem and I would say x plus y equals 1270. And then 15x plus 12y equals 17,625. And I would just multiply the top by negative 15. So negative 15x minus 15y gives me what's negative 15 and 1270. Negative 19,050. So negative 3y equals 17,625. Negative 1425. And then I divide both sides by 3, negative 3. And I got y equals 475. Is that the same thing I got up here? Yeah. And then I just plug back in. So look, either method, same answer. But what you need to understand is this is not the only answer to this question. It's part of. This lesson, these last few lessons, are setting up the system of equations and solving. So this is as much part of the answer as the actual answer itself. I need the proper setup. Some of these questions lend themselves to reasoning skills where you guys can tell me, oh, well, what I did in my head. No, I don't want in your head. I want system of equations set up, then I want them solved. Does that make sense? Everybody understand that? Yes? Okay. Look at the next page, right? Our problems get a little more difficult. We have a back substitution. How do we solve a back substitution problem? How do we solve a back substitution problem? You work backwards. You plug in, all right? Look, this is a super basic question, but look how I showed all of my work. You guys will have a calculator on your desk. That's fine. But you need to show me what you're doing. Be super sure of signs. Positive 13 and negative 13 are a huge difference. Don't tell me, I had the sign here, I just didn't put it. Pay attention to what you're doing. In a question like this, guys, again, see what I have highlighted. There are two parts to this answer. You have to have your row echelon form where it goes 3, 2, 1. The directions on this says solve the system, and it says use Gaussian elimination. That's what this is. Don't say to me, what's Gaussian elimination? The writing was exactly on our notes when we did this. So it's nothing new. But I'm looking for your 3 equations and your ordered pairs. On WebAssign, I had somebody, hang on one sec. I had somebody come up to me and they're like, I think I might have told you guys this, but if I did, I'm going to repeat myself. He got a solution on something on WebAssign, and he told me he got 2 solutions. But WebAssign would only let him put in one. Like, he put in both of them, marked one of them wrong and one of them correct. Legit. Not to this problem, but he got something like 7, negative 14 over 7, and 4, right? Just whatever. And he plugged these 3 numbers in the first equation, and it worked. And then he plugged these 3 numbers in the second equation, and it worked. What should he have continued to do? Plug it into the third. He did not. He just assumed, oh, it'll probably work in the third one. And it didn't. You will not get several different ordered triples for these answers, guys. You have to go back and make sure that it satisfies all 3 of the equations. If it doesn't, that is not no solution. We did problems that were of this nature, Gaussian elimination, there was 3 and it was no solution. You get an untrue statement. If you plug this back in and it does not satisfy all 3 equations, you made math error. Go back and find it. If I were you, I would not try and find it in this mess. I'd erase it and start over. It's probably your best option. Yes, ma'am.
So we have to, how do we know when we have to have the 3 equations?
It'll be it's the only one with 3 equations.
Okay, like the one above, we can't do 3 equations.
No, because it'll say solve using back substitution, but that's already in the 3 equation form.
Oh, okay.
Like I already did the first step for you in that question. You're just finding what the ordered triple is. But again, remember this, guys. What's the rule for solving these? What does the first equation have to be? Positive 1x. So just say you were given these equations. And then this was... All right, none of them start with a positive 1x in this case. Is this one not able to be solved now? No. What could you do to the second equation in this case? Multiply or divide everything by -1. What could you do in the third equation in this case? Divide everything by 2. You will always, with the problems that Ms. Carver and I give you, you will be able to algebraically make one of the equations a positive 1x. You might have to do some math, might have to multiply through or divide through, but you will be able to do it. Does anybody have any questions on these ones? It's really good to stay organized, guys. Here's my set of equations. After I move one to another spot, I like to rewrite them so it's easier. So then here is 1 and 2 right there. Here is 1 and 3 right there. And then here is the result of those 2 to get my z. It's good to stay organized. Questions? All right, you're going to have 2 partial fraction decomposition ones. You're going to have one that you actually have to set it up and solve it. And then there's going to be one where you just have to set it up in bold, capital letters, it says do not solve. So say I have negative 17x plus 4 over x plus 3 to the 4th power. And it's partial fraction decomposition. Do not solve. What does my setup look for a problem like this? How many denominators will I have? How many fractions will I have? Why do you know it's 4? Because it's the power of 4. Say you factor it and you just have 3. You end up factoring it, it comes out 3, then you have 3. So my first denominator here would be x plus 3. What's my second denominator? X plus 3 squared. What's my third denominator? Good. What's my fourth denominator? To the 4th, all right? What are my letters? A, B, C, and D. That's all. If it says do not solve, it's just looking for the setup. Just set the problem up, and then you will have one where you actually do have to solve. When you are solving with the partial fraction decomposition, remember the first thing we do is factor the denominator. And then I always take it one step further and I say, okay, let me just go ahead and solve so I know exactly what I'm going to use to evaluate. And then once you come down here to evaluate, guys, notice in this case, the B canceled out. In this case, the A canceled out. Every single time something should cancel out. You should be left with just one variable. If you have 3 denominators, then 2 of them should cancel out. But you should only be left with 1 because you're solving for one specific variable.
Thank you.
Sure, no problem. And then notice again, I had a denominator with my A term and my B term. Don't leave it like that. Bring that denominator down into the denominator of the bottom. Don't leave a fraction on top of a fraction. If you want to multiply this through, you can, but you don't have to. You can just leave it. That's fine. Yeah.
If the formula was to be a no, don't solve for that one, would we have like the parentheses on the top, or I would just have
No.
like, the A and B like that?
Just if this one was a do not solve, it would be just like this.
Without the X,
Yeah.
Y, Z.
Yeah. You're just setting it up.
What is the 11 in the denominator? We don't have to distribute it?
No.
Oh.
If you do, it's not wrong, but you don't have to. Anybody else have any questions on this page? Yep.
If you have a fraction as like negative 5 over 11,
Mhm.
that whole thing, do you have to move the negative over and change it to a subtraction, or is it fine?
You can if you want. Like if you have, just say you had 7 over x plus 3 minus or plus a negative 5 over x minus 1, right? You guys are fine with leaving it like that. I'm fine. If you write it as 7 over x plus 3 minus 5 over x minus 1, that's fine as well. If you write it as negative 5 over x minus 1 plus 7 over x minus plus 3, that's fine as well. As long as your signs are correct, in all 3 of these cases, this fraction is negative, correct? In all 3 of these cases, this fraction is positive, that's fine. As long as your signs are right and that your denominator matches with the variable you were solving for. Questions? Let's look down here at these last ones. All right, guys, it's important, right? Some versions might have a word problem that talks about perimeter. There's some stuff that's just called common knowledge. You guys might see something like this in the SAT or ACT and you're like, well, I'm not in a geometry class. This is not geometry. This is basic knowledge. My kids are working on this and they're in kindergarten. What does the word perimeter mean? How do you find the perimeter of something? You add around. So if something has 4 sides, you're adding 4 numbers together, right? So this problem says, whoops, it says the perimeter. Here we go. The perimeter is 78 meters of a rectangle. Okay, so just think about that. Draw a picture. Here's my rectangle. When I add up all the sides, my perimeter is 78 meters, right? So the next part says that the length is 5 meters greater than. Okay, so which one is the length? The one on top, bottom, or left and right? Does it really matter? The way I drew it, the length is longer than the width. So where would it be? Length would be here, and the width would be here, right? You guys agree with me? So this problem, one of my equations would be W plus L plus W plus L equals 78. What's another way I could rewrite that? 2 W's plus 2 L's equals 78. If you guys don't like using W and L, what are 2 letters that you could use that we've been using? X and Y. Okay, fine. So here's an equation, right? I need 2 of them. I need a system of equations to solve this. The second part of this says the length is 5 meters greater than the width. What does that mean, greater than? You add 5. It says the length is 5 meters greater than the width. So the length is means equals, 5 meters greater than the width. The length is 5 meters greater than the width. What is this set up for me to do? If I know what L equals. With this information that I have right here, how could I solve this? Here's another equation. Look, do you see this other equation we just made? Could I use elimination? Absolutely. You can put the L's under the L's, the W's under the W's, and the numbers under the numbers. That's fine. But what did you just say, Elliot? What could we do? I could take this and put it right there, can't I? So 2W plus 2 times, instead of L, I have 5 plus W equals 78. And then you solve. Whatever you find W, you plug it back in to find what? L. If you want to change everything to X's and Y's, guys, do that. Make X the length, Y the width, whatever. If something says, like in this next one here, it says the width is 50 centimeters less than. If something is 50 centimeters less than, it's minus 50. If it said triple, if something was triple the length, what does that word mean? Triple. Times 3. If it said double, times 2. If it said twice, also times 2. All right, you guys, you know all those math words. If you're not comfortable with the W's and the L's or something like that, change everything to X and Y. That's totally fine. Another thing I want to bring to your attention, say you have a problem like this. Can you just go ahead and use substitution or elimination the way that this problem is written? Why not? It's not, so you guys have to have, if you're going to, anytime you go to solve substitution elimination, you have to have x's on top of x's. So you'd have to rewrite this as 4x minus 3y equals 7, agreed? And then this would be 9x plus 7y equals negative 15. Now feel free to do what you want. I just made these numbers up, so this probably doesn't work. And if it does, it's a miracle. Now, go ahead and use substitution elimination, but you have to have everything. You have to have x's on top of x's, y's on top of y's, numbers on top of numbers before you can go ahead and start the process. Everybody with me? We okay? All right, word problems like this. I was going to put something on the quiz, but it was just ended up being a little too long. You will probably see something like this on a test because I'm not going to re-quiz you on everything that we've done. So it'll just be 1 or 2 from these couple sections on your test. So just be aware of it. This is the same kind of interest problem that we did at the beginning. If you look, you have 3 different accounts. That's my X, Y, and Z. And that is my $775,000 that I put in. Then I have my 3 accounts and my 3 interest rates. Interest with interest with interest. The last equation is just one additional piece. The last equation, it says the amount borrowed at 6%. Well, what variable did we use for 6%? Which variable is 6%? X, that's what I chose. You could have done whatever. But the amount at 6% is 4 times the amount at 8%. So the 6% amount was X, the 8% amount was Z. 4 times that would be 4 times Z. And then you do your manipulation. Again, that's not going to be on the quiz tomorrow. I just want you guys to see that. Same thing with the golf course problem. It's on the next page. You got 18 holes. You have a par 3, par 4, par 5. That equals our 18 holes. A par 3 should take 3 strokes to get it. Par 4, you should take 4. Par 5 is 5. For a total of 72 strokes. God bless you. The last equation is the one that says there's twice as many par 5s, you know, whatever. I don't know exactly what the wording was because it's on the previous page. But just understand that any of the word problems we're talking about, if you're talking about food, if you're talking about adult tickets versus children's tickets, if you're talking about hamburgers and French fries, we're talking about 2 different variables. Every single time, make it X and Y. To help yourself out a little bit, right, X is standing for whatever. Y is standing for whatever. Because I am looking for the equations, how you set them up, and I'm also looking for your answers. Everyone understand? Does anyone have any questions? Yeah? No? No? Okay. All right, let's do a partial fraction decomposition setup. So you guys know this is just a setup. This is not a solve. This is a setup. I want you to know exactly what we're expecting the answer to look like. So say we had, hold on, I got to make something up real quick. 4x plus 7 over, all right, so say you have this problem right here, and it's partial fraction decomposition, just the setup. I want you to know exactly what we're looking for as far as an answer is concerned. So the first thing we should do here is what? Factor. All right, if I'm going to factor this denominator, 6 times 4 is 24. All right, so what are the factors of 24 that multiply to give me 24, but add to give me 11? So x plus 8 and x plus 3. Okay, fair enough. So my a term is not 1. Whoops. So I need to divide both of these by 6, correct? So then this becomes 4 over 3. And this becomes 1 over 2. Yes or no? Okay. So my 2 factors in my denominator are 3x plus 4 and 2x plus 3. Does everybody agree with me? Okay, so the setup, exactly what we're looking for. So there's no gray area of, well, I didn't know exactly what I was supposed to do. Your setup, because it's just setting up, we want to see the decomposition. What are the 2 parts that you broke it down into? So your denominator was 3x plus 4. And the other one was 2x plus 3. Okay. And then I have an A and I have a B. Now, to finish the setup, because you want to make this balanced, you want the left-hand side to be equal to the right-hand side. What is the A numerator missing? It has the 3x plus 4. What is it missing?
2x.
The 2x, what? Plus 3, okay. B has the 2x plus 3. What is it missing? The 3x plus 4. So if you are asked just to set up, this is what we're looking for. You want to make an equivalent statement. So the left-hand side is equivalent to the right. Because look, you're going to multiply the bottom here by 2x plus 3, so you're going to multiply the top. Here you're going to multiply the bottom by 3x plus 4, so you multiply the top. Yes?
It's not 2x plus 4, maybe 2x plus 4.
Ay, guys. This is a 1. Guys, when you see me make a mistake, don't wait until the very end. What I miss it. So this is a 1 here. Duh. I can write. I gotcha. Better?
Wait, so the whole thing, everything is the answer?
This is the setup because you want the left-hand side to be equal to the right-hand side.
If, say, like, it was 12x and you can divide out, like, 2, how, like, would the 2 get its own, like, fractions? Like, would it be, like, a over 2, like, plus?
No, if it's just a constant by itself,
Yeah.
we're not going to give you any like that.
Okay.
There's a different explanation for that one. So.
Is there gonna be
Yes, we're going to go over one in a minute. Hang on.